So we were talking about the Schrodinger equation and the wave function. It is the mathematic expression and these are the constant. Also, we will discuss about what is the A and how can we calculate the A and what is the K, and X is the on the X direction, the particle moving on the X direction, that means it is the translational motion. The first we will discuss about the translational motion. And this is a solution here. The A value of A is 2 over L, under root 2 over L, and the K value is N pi over L. Again, I will discuss about how can we get all these values. And this is very important. And if you know all the steps involved to derive this equation, and you can do a very simple equations, how can we use to derive. And the other factor is the psi square, the square of the psi. And actually this is giving you the probability density or the location of the electron. Where is now the probability of the finding the electron. So there are two ways. One is the wave function, other one is related to the particle. So there is the dual property, wave-like and the particle-like. So with the psi we will find out what are the wave function, and with the psi square you can find out what is the electron probability density, or describing the probability of finding an electron in a given volume of space. Say given volume space means in a shell you can find out where is the, how much is the probability there finding of the electron. कहाँ पे इस वक्त होगा वेव में, वेव आपके पास पूरी आपके पास लेंथ चल रही है, तो वो स्टार्ट में होगा, एंड पे होगा, किस जगह पे इलेक्ट्रॉन अभी उसकी जो है वो पॉसिबिलिटी कहाँ पे होगी. सही है. सो दिस इज साई स्क्वायर. तो साई स्क्वायर आप लेंगे तो सिंपली मैंने ये ऊपर साई लिखा हुआ, इसी का स्क्वायर लिखा. ठीक है, इसको स्क्वायर लेंगे अंडर रूट खत्म हो जाएगा, ये आपके पास आएगा. और ये इस पूरे का स्क्वायर लेंगे तो ये थीटा का, ये आपके पास जो है साइन का स्क्वायर आपके पास यहाँ पे, बाकी फैक्टर आपके पास वैसे ही रहेगा. ठीक है. एंड साई स्क्वायर इज psi multiplied by psi. So there are the two forms we will again discuss. One is the real one, other one is the imaginary. So here the first one is the quantization of the kinetic energy. सही, आपने पहले इसका जो फोटोन को डिस्कस हमने किया है. दिस इज द E is equal to h mu according to the Planck's constant. Now we are going to quantize the kinetic energy. So what is the kinetic energy at the first level, and what is the kinetic energy at the second level, and what are the kinetic energy at the third level. तो आप देखें दो ग्राफ आपके पास हैं. This one is the potential energy. This is the zero level energy. It is written potential energy when at the ground state it is the zero. And this is, and 1 is the first level, and 2 is the second, and 3 is the third level. This may you consider as the principal quantum number जो है. सही, KLM की बात कर रहे हैं. And now this is the wave. First one is the energy level, and these are the wave function, and this I have explained. Wave function जो है इसको हम एक्सप्लोर करेंगे, बट यहाँ पे हम इसकी वैल्यूज निकाल रहे हैं to find out the kinetic energy. ठीक है. So at level 1, this is the level 1. How many waves are there? Half. Okay. So this is the actually the particle in a box. इसको मैंने जैसे this is the box. So what is the length? Length is starting. Electron is starting from this point, coming out this point. So this is the zero, this is the maximum length. I'm not, this may be a 1 foot or 1 centimeter or 1 nanometer. It depends what is the length of the box. Okay? And X is giving you the indication where is the position of the electron, or we can say this is the X direction. Okay? ये total distance है. ये अब आपको बताएगा how many waves the electrons have traveled in the N1 or the first level shell. तो अभी आपने कहा कि आपके पास जो है कितनी इसकी है वेव कितनी है, या टोटल L कितना ट्रेवल किया, हाफ X. ठीक है. L यहाँ पे आपके पास क्या है, L is the दिस इज द टोटल डिस्टेंस। इसमें जो है वो कितना ट्रेवल किया इसने, एक्स एक्चुअली हियर इट इज द लैम्डा आई एम गोइंग टू शो, ठीक है। तो कितना ये ट्रेवल किया, यहाँ से लेके इसने हाफ ट्रेवल किया, पूरे बॉक्स का जो लेंथ है उसका हाफ इसने जो है वो ट्रेवल किया, वेव लेंथ इज दी हाफ, ठीक है। पहले बच्चों मुझे खत्म कर लें, ठीक है। अब आप देखें एल, टोटल एल इज दी half x, or you can say half lambda. And how many halves are there in the second? 2 halves. Total L कितने के बराबर होगा? x के बराबर होगा, या 2 half आपने कहा है, this is shown over here. Total L जो है that means 2 half of the x as compared to the first one. 2 is cancel out, that means it is actually it is the x, or x is actually it is the lambda, सही है। And this is 2 over 2 cancel out, the remaining is left is lambda, and it is also shown over here. There is no need to have this calculation, ठीक है, लेकिन इसको हम आगे यूज करेंगे, इसलिए मैं साथ साथ इसका बता रहा हूँ। चलें, फॉर द थर्ड वन, हाउ मेनी द टोटल लेंथ इज इक्वल टू हाउ मेनी लैम्डा? शाबाश, आप बताओ। 3/2, 3 हाफ, शाबाश, 3 हाफ कहें या 3/2, 3 हाफ को 3 हाफ से मल्टीप्लाई करेंगे, दैट विल बी इक्वल टू 3/2, एंड दिस इज शोन ओवर हियर कि L इज इक्वल टू 3/2 x और 3/2 लैम्डा और 3/2 लैम्डा, ठीक है। नो व्हाट इज द जनरल इक्वेशन ऑफ दिस वन? एक्चुअली यहाँ पे अब आप लैम्डा को ले रहे हैं, और ये यहाँ से हम बात आप कर रहे हैं कि हम ड्राइव इसी से लेके हम कर रहे हैं। So for the first level, that distance traveled by the particle is half lambda. For the second level, it is lambda. For the third level, it is 3/2. For the fourth level, it will be 4/2, and this is 2 lambda, ठीक है। ये सेकंड का जो है इसका वो डबल है, इसका 2 lambda, इसी तरह so on it will be carrying out. So this is the general, that means equation is L nx over 2 or n lambda over 2. यहाँ पे n is 1 2 3 4 again integer number, and you can put the value and get the answer of any of the energy level. इसमें देखें 5 करेंगे 5/2 आ जाएगा, 7 करेंगे 7/2 आ जाएगा, ठीक है। 4 करेंगे 4/2 और 2. So anything you can put and get the value of all these, the wavelengths traveled by the electron in one dimensional box with the length starting from 0 to L. Clear है ये? Now अब देखें ये इंपॉर्टेंट है, इसको अच्छी तरह इसको अंडरस्टैंड कर लेंगे, ये हम अगर ये बेसिक क्लियर नहीं होगा तो आगे इट विल बी डिफिकल्ट टू अंडरस्टैंड ऑल दीज स्टेप्स. So actually now I'm going to derive this, the energy at level 1, energy at the level 2 and 3 and so on, and this will be the kinetic energy. Kinetic energy, simple equation for the kinetic energy is half mv square, and where there is no lambda is there, because here in our case is the wave is important. Now we are putting the wave into the half mv square to get the kinetic energy of the particle moving in one dimensional box and with the wave length. This is the equation we have derived before. This is the L is equal to n lambda over 2. सही है, पीछे यहीं पे हमने वाइंड अप किया, पिछली साइड में यही किया ना हमने, सही। n is any number, उसके स्लाइड्स के ऊपर देखते जाए, ठीक है। and what would be the lambda? Just it is a rearrangement. lambda आपने निकालना है, and 2 मल्टीप्लाई करेगा and डिवाइड कर जाएगा, ठीक है, very simple. And then according to the de Broglie equation, what is this was we have already discussed and derived this equation. Lambda is equal to h over mv. M is the mass, v is the velocity, or we call mass into velocity is the momentum. Second equation, h equal to rho or h over mv, that is the same thing, ठीक है। Now why I have used the de Broglie equation? to put the value of the lambda, because this, the first one lambda is a 2L over n, second is the lambda h over mv. So put the value of lambda in de Broglie equation, and this will become this. So you are replacing the wave lambda in the de Broglie equation by using the first equation we have derived by using the graph. Clear है ये? यहाँ तक कोई difficulty? Second, now I am putting the mass into velocity. Mass into velocity आपने निकाला. Again, this is just the rearrangement. आपके पास क्या है? 2L divide कर जाएगा, h जो है वो n के साथ multiply कर जाएगा. Just this is the rearrangement. And why I have calculated or the drive mass into velocity? Kinetic, because the kinetic energy is the half mv square. So this is the way. आप steps याद रखें कि objective क्या आपका और starting point आपके पास, ठीक है? Now kinetic energy is the half mv square, and here is the v square, ठीक है? लेकिन momentum आपके पास है mass into v, तो आप क्या करें? Multiply and divide by m. दोनों तरफ से आप कहते हैं that is the same thing. Nothing will change with the multiplication and the divided at the same time. ठीक है? 2 से multiply करें, 2 से divide करें, वही चीज आपके पास आएगी. Now the equation will be E m square v square divided by 2m. ऊपर वाला m है वो m square हो जाएगा, नीचे एक m आ जाएगा. तो that is the, we are multiplying and dividing by the m. Clear है ये? Now square root of the momentum, ये momentum जो already हमने की है, this arrow is going to show, सही? तो mass into velocity, mass square, velocity square सारे double हो जाएंगे, सही? Square हो जाएंगे. तो it will be n square h square over 4 l square. Clear है ये? Now put the value of this in the above equation. Kinetic energy के formula में आप put करें, and this will be give you the value n square h square over 8 m l square. Clear है ये? So this is the actually the kinetic energy. You can calculate. अब देखें ये L square is important. This because this is the length of the box. सही है? वहीं उसके अंदर ये पैरामीटर आपके पास आएगा. And m is the mass of the electron, 8 is the constant, h is the Planck constant, and n is the energy level जो है, सही है, जिसकी हम बात करें. First energy level, second energy level, third energy level. So this is all about the kinetic energy. But I am going to finish over here. This is the final equation. Okay, I am just rearranging this equation. As we have said, kinetic energy we have drive over here, multiply by divide, and this will be the kinetic energy, half mv square. And again, but just for the simplicity, mu mv is the rho, and rho is the momentum, and I am just replacing the mass square v square with the mu square, rho square. समझ में आ रहा है? This is the rho, and because these are the square, so this will be also a square. ठीक है? So I am just replacing now here with the rho. This is the momentum, and this is the kinetic energy. You can use even this formula or the previous formula. ठीक है? दोनों आप यूज कर सकते हैं, और ये भी इंपॉर्टेंट है क्योंकि आगे मैंने इसको भी यूज करना है, तो इसको आपने अलग से कॉपी के ऊपर कम से कम, क्योंकि सारी चीजें जो फौरन नहीं याद रहती, वहां पे देख के आप बता सकते हैं. ओके, दिस इज द आल्सो फार्मूला टू कैलकुलेट द kinetic energy. Again, just rearranging the above equation, rho square will be equal to 2me, and the rho will be under root 2me. 2 is constant, m is the mass, e is the kinetic energy. So this is another formula for the momentum. So momentum is the mass into velocity, and the momentum is also over here. You can also calculate the momentum by using this equation. ठीक है? And these are important because these equations, simple equation, we will be using in the future derivation here. So must remember, try to understand, and at home, I suggest to solve by watching the video. You should start again driving this equation, and the important is the steps involved and how I have explained. you have to explain in your notes or the final exams as well. Otherwise, these alpha bats doesn't have any values.